And now, next picture. Do you remember the term meridian? We know that Earth, our globe, has a lot of meridians. How much? At least 360 meridians. So, we can divide our globe, our Earth as a planet, into 360 planes which are similar one another. And the same way we can divide the eye bulb into meridional planes. We can make meridional sections of eye bulb. How much of meridional sections can we make through the eye bulbs? Again, the same like for our planet, for globe, at least 360. And this is, on this picture, example of MRI section. MRI, magnetic resonance imaging film, which demonstrates us horizontal section through the orbit and through the eyeballs. And this horizontal section is an example of meridional section, one from 360, which coincides with horizontal plane. And for us, it's very important to understand what is meridional section. It is section which connects the most anterior point on the external surface of eyeball and most posterior point on the external surface of eyeball. Please be attentive for very interesting feature in this scheme. It isn't scheme, it is real MRI imaging, that eyeball fulfills not the orbit completely, but only 1/3 part of it. So if we have learned last year that orbit has a pyramid-shaped cavity inside of the skull, so from this pyramid only basic part of it, on the entrance of pyramid we can find an eye bulb, and the apical portion of the pyramid isn't fulfilled by the eyeball, but what we can find here, the connective tissue and the fat. That's why when we look at the eyes of one another, usually we can, without any questions, understand. Have this man enough time for sleeping today night, how to say, this night or not? For example, he had not good rest, his eyes is deepened inside of the orbit. And also, if we see the patient after very long time fasting, of patient who had not eat very long time, also the eyes becomes deepened inside of the orbit. It is due to this connective tissue which fulfills the large part of the orbit, and eyeballs are located only in the basic part of it. Next, very interesting detail which we can explain to ourselves is that optic nerves, they are directed on the angle according to the middle plane. So the axis of left and right optic nerves, they meet each other here on the sella turcica region. So we can remember that there is so-called chiasma opticum, where two optic nerves, they meet each other and they connect with each other and they cross the fibers from right and left eyes in this place. And it is strange. Maybe not strange, but it's understandable that it should be this way. But if we try to compare the axis of visus and or axis opticus and axis of optic nerve, they are quite different. So another very important detail is that in a norm, using two eyes, we can see the same picture, which is single picture for two eyes. And if we can see two different pictures which does not coincide, that means pathological type of vision, which called diplopy. Diplopy, from the Greek word di, which means double, which means that we the same time see two different pictures using two different eyes, and they does not coincide. It's interesting that such type of vision is a character for the drunk man. After drinking alcohol, the drunk man can't concentrate his vision, and his two eyes see not coinciding pictures. And this is again diplopy. But in not drunk man, this type of vision is pathological. So we need inside of our brain to see the one picture. And now when we understand this meridional section of the eyeballs, in this MRI picture we have a meridional section in horizontal plane of both eyes. But now I propose you scheme from the textbook of Sapin of right eyeball. So let's try to compare. So here it is, number 12, nervus opticus, and it is directed into medial plane. So posteriorly it should be meet with left optic nerve. So that's why in meridional section in horizontal plane we can find large peripheral or temporal portion of the eyeball and lesser the nasal portion of periphery of eyeball. It is due to unsymmetrical positioning of optic nerve, and we can understand it looking at this section in MRI imaging. And now let us compare this picture with complete designations, for we can distinguish each detail. We already have drawn this scheme previously. That's why practically now we can understand all the details here. And now I'd like to opposite the meridional section of the eyeball, which could be made 360 times through each eyeball, with number 16 axis, which is transverse or equatorial section. Again, let us remember geography. Our planet, our globe, has a lot of meridians, and our globe has only one equator. And this equatorial plane is single for each eyeball. So equatorial plane divides the eyeball to anterior portion and to the posterior portion. So, comparison between meridional section and equatorial section of eye bulb is that due to equatorial section we divide eye bulb from anterior and posterior portions which are different, and meridional section should be always practically the same. All 360 meridional section should be the same for the eye bulb if we look from internal surface, except positioning of the discus nervi optici. And now again let's return to this designation, number 14, external axis of eye bulb. Or we can say it is anteroposterior diameter, which is 24 millimeters. This diameter connects most convex points of the eye bulb. One of it, the anterior pole point of the cornea, and another in posterior pole of the bulb, located 2 millimeters laterally from the optic nerve. So here it is. Here it is, optic nerve. Here it is, number 13. Number 12. 13 is discus nervi optici. And this red line is located laterally to nervus opticus. So, if it is horizontal section, for right eye, again, this is temporal peripheral part, and this is nasal or medial peripheral part. So, number 14, external axis, connects these 2 points, anterior pole of the cornea and posterior pole, which is 2 millimeters laterally. It means on temporal side displaced point of the bulb. And again, let's repeat that 24 millimeters for all healthy men, for all men who can see good without any glasses. And now the next axis, here it is. Number 19, axis opticus. Number 19 is axis which connects the internal surface of the cornea and the central fovea of retina. Central fovea of retina. Again, this distance always should have the same dimension, 21.75 millimeters, and not more. Very interesting situation. And now I'd like to demonstrate you how the light waves can reach the place of internal surface of eye bulb for good vision. This is an example of the eye bulb which see to the long placed subjects. For example, when we watch the landscape. So here it is, 3 parallel placed light waves. They enters to eyeball through the cornea, then they penetrates the lens, and lens change the directions of each of 3 lines, and they meet normally exactly in retina. So, function of lens is to concentrate each waves of the light exactly into retina. Such type of vision of healthy eye calls emmetropy. So normal vision, emmetropy, the good vision. And such kind of man it calls emmetrop. Good seeing man without any glasses calls emmetrop. And now another example. First of all, you can see that this eyeball is extended in anterior-posterior dimension. This eye bulb is enlarging it in anterior-posterior dimension. And that's why, without any glasses, all 3 lines of light waves, they meet each other before the retina. So such kind of situation results in not good seeing. Such kind of seeing isn't clear. Such person could be see good the subjects which are close to his face, which are near his eyes, but without glasses, such patient can't see clear, can't see good. And for correct this lines of light waves, he need to use a special glasses with lens of two cavital surfaces, so concave glasses with minus dioptries. The glasses with minus dioptries, they have such kind of lens, and this lens provides the direction of light waves exactly on the retina. Such type of vision calls myopy, and such kind of patient calls myop. He is myop. And third type of the vision is presented in low row, and you can see in comparison with the most high picture that eye bulb was diminished in the anteroposterior diameter. So the lines of light waves, they meet each other posteriorly to retina, and again such patient can't see good without glasses. But for correction, the directions of the light waves, he need use another type of glasses. He will use two convexite type of glasses, which use the plus dioptry. So this patient calls hypermetrop, and this type of vision, of pathological vision, calls hypermetropy. So this example is very important for understanding that exactly anteroposterior dimension of the eye bulb, it is responsible for good seeing, and today we have another very widespread problem with ability to see, which is connected with the civilization, which is connected with necessity to read, to use laptops, gadgets. They need to make a focus of our eye to the near located to our face subjects. So this is very difficult for muscles of the eyes, and contemporary men, as a result of this situation, usually use the plus glasses from 40 or 45 years old. So those men who had a good ability to see, who didn't use the glasses before 40 years old. After 40 years old, they should have a plus dioptry glasses for good seeing. This type of seeing goes with another term, presbyopy, because presbyter in Greek means older man, presbyter, the older man, and for old people in today in countries of high civilization, when all people can read, can write, when all use the gadgets, computers, all these men and women, unfortunately, ought to use plus dioptry glasses after 40, 45 years old. This is presbyopy.